I'm sorry, what? That's right. The French word for mountain, which by the way is monton. No, actually, I don't speak French. Anybody speak French? Anybody speak French? Yeah. The French word for mountain starts with an M. And since mountains have definite grades or slopes, yeah, M is typically the letter used. I think that's what Descartes, who born in France, so he spoke French, so used M to designate the slope of the line. So M is going to be delta Y over delta X. You folks that have had physics or physical science, delta means your fraternity, right? No, delta means change in, yes. Change in the Y's. The change in the Y's over the change in the X's. That's what delta means. You take your physics, you're going to see deltas all over the place. Which means change in this, change in that. Change in temperature, change in pressure, change in whatever. But ladies and gentlemen, if you want to find the change in something, you're going to have to subtract. If you made a 70 on your first test, and an 85 on your second test, I said, what was the change from the first to the second? You go, well, let me subtract 15 points. All right? So delta implies subtraction. So what you got is, it's going to be y minus y over x minus x. But hang on just a doggone second, that's confusing. Unless we do exactly what we did on the distance formula, this guy's going to be x1, y1. This guy's going to be x2, y2. So it's going to be y2 minus y1, x2 minus x1. And you probably remember in the distance formula, it didn't make any difference which one was x1, y1, which one was x2, y2. Same here, doesn't matter. So if you wanted to kind of push the envelope, you know, kind of be rebellious, and say y1 minus y2 over x1 minus x2, you get the same slope that I would. So it's just y minus y, x minus x, in the same order. Make sure you keep it consistent. And let's see what that means. That means y2, that's 11, minus y1, which is 5, x minus x. I get 6 over 3. I still get 2. And I didn't even need a piece of graph paper to do it. I give you 2 points. If I give you 2 points, say what's the slope of the line between these 2 points? Say what's the slope of the line between these 2 points? You're going to put it into the slope formula, which is y2 minus y1, x2 minus x1. That's 3 by 5 card worthy, ladies and gentlemen, right there. That is a good choice for your 3 by 5 card. Because you're going to be figuring slopes multiple times in the stuff we do from here on. So anytime you got 2 points, slope is just asking to be figured. x1, y1, x2, y2. Let's see. It's y minus y, 1 minus 7. X minus x, negative 1 minus 1. Drop those negatives. That's a negative 6, or a negative 2, whoops, or a negative 2. That is a positive 3 slope. And think about it. If you'd reversed it, you'd have had 7 minus 1 on top, 6, and you'd had negative, or you'd had 1 minus a negative 1, which is 1 plus 1, 2. You'd have had 6 over 2, you'd have still gotten 3. So it doesn't matter which one's x1, y1, which one's x2. Yes?
For that, the rise or the run thing, so those are basically the same, right? So if we just want to take a shortcut.
They're the same thing.
So yeah, so if you want to just take a shortcut, we can just use this rise or the run.
If you have a graph,
If you have a graph,
and you can count vertical and horizontal distances, rise over run is a good way to do it. If you just got 2 points on a piece of paper like this, don't need any graph paper, just y minus y over x minus x. Delta y over delta x. Hey, so if you were given 2 points, did you find the slope?
Yes.
Go x1, y1, x2, y2, fill in the formula, simplify it, you got it. You're going to have some opportunities to do that on your website.
What's this unit called in the website?
Equations in two variables. This is equations in two variables.
Oh, wait, one more question.
Linear equations in two
Linear?
variables. Yeah.
Dr. Brice. Okay.
Which brings us to our two variables. When you have an equation of a line, yes, ma'am.
You can't have a negative slope on.
You can't what?
You can't have a negative slope on. It's undefined.
We'll get to that in a second.
Oh.
Just hang on to that question. I'd be amazed at the answer. All right. When you have the equation of a line in two variables, it will typically look something like this. When you have x's plus y's equal a number, this is called standard form. And standard form is good for, it's wonderful for one particular thing, finding the x and the y intercepts. You agree with that? Hey, what do you do to find an x-intercept?
Make y
Let's
zero.
say right
You
at
let
0.
y equal 0. So what's this? We're going to let y equal 0. That means that 3y is 0. That means that 2x is 6. X must be?
3.
Got it. How do you find the y-intercept?
6, 0.
Set x to 0. If x is 0, that means 2x is 0. 3y is 6. Y must be 2. And once you got those 2 points, you got the line. 3, 0. 0, 2. Here's your line right there. That's 2 points. That is one advantage of standard form. Very easy to find the intercepts and thus to graph the line. But the more workable, usable, the one I'm going to request you to find is in a different form. It looks kind of like this. You know what that's called? Very good. Slope intercept form. By the way, what is that? What does that letter in front of x represent? The slope. It's still m. It's still the slope. And b is what kind of intercept?
Y.
The y-intercept. Very good. So bottom line, if I solve an equation, linear equation for y, like this, then the coefficient of x, the number in front of x, is my slope. There it is, visible. And the constant number at the end is my y-intercept. So for instance, if I took this equation right here and solved it for y, I would get y equals negative 2/3 x plus 2. If I said, what's the slope of that line, you'd go, that's easy. What is the slope of this line?
Negative 2 3.
Negative 2/3. And what's the y-intercept? 2. Or you could say it's the point. 0, 2. Either way. Well, speaking of slopes, we probably need to make some general observations about the slopes of lines. Everybody got this okay?
Mm-hmm.
Now, I don't want you to count any rises and runs. I don't want you to find any points, anything like that, because I just want general answers. As I look at this line right here, moving from lower left to upper right, what do you know about the slope of that line?
It's positive.
Very good. This is a positive. This is a good example of what a positive slope looks like. This is what, in general, your GPA is doing semester by semester. It's just gradually climbing up into the academic stratosphere of achievement. At least you hope that's what your GPA is doing. Tell me about this guy right here.
It's negative.
That's a negative slope. And you're not surprised. If you guys look at the stock market, or if you look at a Wall Street Journal in the back and see all the graphs, this is what you want to see when you're, if you're talking about the stock market, if you're talking about your 401k, this is what you want to see. This is what you actually see. The last couple of years. Your 401k is probably like a 201k now. Lost significantly. But yeah, that's a general idea. You got something moving from lower left to upper right, positive slope. Don't even have to count. Don't even have to do any figuring. Negative slope. Got it. Well, there's two other kinds of slopes. These are general, positive and negative. I got two more kinds of lines other than those. And those are horizontal lines and vertical. Now, you can always figure the slope of a horizontal and vertical line by using your slope formula. Remember it? Y minus y over x minus x. Hey, I need a couple of points. Let's find a couple of points on this horizontal line, like 0, 1, 2, 0, 4. And 0, 1, 2. Let's do 4, 4. Any 2 points would do, right? Any 2 points would do. So let's find the slope. It's y minus y over x minus x. Everybody okay with me leaving out the formula? Y minus y over x minus x. It's 0 over 4, which happens to be
0. And we fine.
That's why you got your calculator. We see we're 2 months into college algebra, and we still don't know if 0 over 4 is 0 or undefined. But your calculator still.
It's 0.
Which one is it?
0.
It's 0. It's 0. Remember this: a 0 in the numerator. That's okay. That's all right. This just gives me 0. It's the 0 in the denominator that's the problem. That's the thing we can't have. That's the thing that results in the undefined expression. So check it out, ladies and gentlemen. The slope of a horizontal line is
0.
0. So if you have a horizontal line, slope is 0. And that logic works in both directions. Here's the way the logic works in both directions. Got a horizontal line, the slope is 0. How about this? If you have a line whose slope is 0, it's horizontal. That's right. You got a line whose slope is 0, it must be horizontal. So the logic works in both directions. All right, let's check out this bad boy right here. That's negative 3, 0. And here's negative 3, 1, 2, 3, negative 3, 6. Just pick any 2 points on that vertical line. And I'm going to do exactly the same thing. Y minus y over x minus x. That's going to be 6 minus 0. I'm sorry, 6 minus 0 over negative 3 minus